Hi everyone, I'm Abhishek, and today I'm really excited to have Savin with me. He's the co-founder of Outerbounds and one of the original authors of Metaflow, which all of you might have heard of. Welcome, Savin. Really excited to have you here.
Yeah, thanks, Abhishek. Thanks for having me here. Excited to be here.
Awesome, Savin. So, Savin, I have so many exciting things to talk to you about. I have so many questions in my head, but I'll just start with just tell me briefly about your journey, Savin, like the different experiences that you have had so far, and uh, just just a brief into that would be great.
Yeah, for sure. I think it was an accident that I ended up in Silicon Valley. I had quite literally no plans to build a career in technology, especially when I was an undergrad. But in many ways, an opportunity to be a part of a Silicon Valley startup knocked at my door, and I thought that it would be sort of like a great experience to have on my resume. And so after finishing up my undergrad in IIT Delhi, then I decided to sort of like pack my bags and go to California. It also helped that pretty much almost everybody in my class was also moving to the Bay Area. So it sort of like in many ways was college all over again. And that sort of like 2 years that I had given to myself as sort of like a quick experiment have now turned over to well over a decade. And it's interesting that I found myself in a role where I was kind of like a go between a team of data scientists and a team of software engineers. And ML engineering wasn't a title that existed. And this is like just like 10 years ago, which seems sort of like if you look at sort of like how AI and ML have taken over the world and how popular world or the vocation of ML engineering is, almost sort of like sounds unbelievable that it just wasn't even a thing just like 10 years ago. And that experience basically educated me significantly around the value of just like experimenting early on in your career. So from that early stage startup, I went to a big tech company by the name of LinkedIn, and then that brought me to Netflix, which was sort of like really popular in Silicon Valley circles about their rather unique corporate culture. And Netflix provided a really great opportunity to experiment and build out machine learning infrastructure. And that sort of like then yielded Metaflow, the open source machine learning platform that we open sourced back in 2019. And then continuing that journey forward, 3 years ago, me along with my co-founder Wille, whom I met back at Netflix, we decided to leave Netflix and start Outerbounds. So yeah, it's been sort of like a sequence of experiments that have sort of like brought me to where I am, and just I feel every single day beyond lucky to have been afforded many of those opportunities.
Nice. That's quite a fascinating journey. Want to hear a little bit around your experience at Netflix. How did Metaflow start? And
Mhm.
as you mentioned, there was no ML engineering title back then. So, and did you have any prior ML experience? Like, how did you land up in this spot in the first place? Like
Mhm.
at the intersection of these two teams. So, just curious about that.
Yeah. So it's funny in the sense that of course I was enamored by the world of machine learning and data science, and I expressed my interest that okay, like if let's say I can pick and choose what team I get to be on, I would want to be a data scientist or I want to do something with machine learning. And then turned out that the world that we used to live in back then was very different. There was no TensorFlow, no PyTorch. So there was an expectation that you would sort of like read up research papers, you would implement a bunch of machine learning algorithms, and then you would get around to training your machine learning model, right? So you can imagine me being one of those persons on the team who had a strong background in software engineering and computer science, not as much in-depth background in machine learning. So building sort of like these tools in
Hmm.
many ways fell on my shoulders. So even though I was part of the data science team, much of the work
Okay.
that I was doing resembled what ML engineers of today are doing. And of course, many of those tools, many of those approaches have been significantly democratized since then. I don't think these days people in every single organization that are doing machine learning are actually implementing their own algorithms, which actually used to be the thing, a decade ago. So that was sort of like one early facet. And then the other thing was, even though I liked the math and the engineering behind machine learning, I don't think personally, I had the patience to run a whole stream of experiments that are absolutely necessary in the world of data science, right? So I think it was also sort of like, in many ways, a personal proclivity towards doing something in ML, but then at the same time, not really having the patience or the discipline of experimentation that are needed to sort of like really be successful as a first rate data scientist. That sort of like prompted me to focus more on building tools.
Understood. So, like, when you joined Netflix, like that, was that the first experience towards data science that you started, or you had done a bit of data science before, or?
No, no, yeah. I mean, I'd sort of like I started my career back at this ad tech company that was involved in real time bidding called Rocket Fuel, and
Yeah.
that was where I got my sort of like first taste of what does enterprise machine learning looks like, right? Because
I
at
see.
that particular moment, either you were sort of like in a fintech company, or you were in big tech, or you were in ad tech. These are basically the three areas where machine learning adoption was really sort of like far outstripping any other company or
Right.
any other area. So that's where I started, and it was in many ways an offshoot of big data infrastructure as well. So it
True.
wasn't sort of like machine learning platforms or ML infrastructure wasn't necessarily a thing. There was an expectation that you're sort of like building on top of your existing data infrastructure or your existing data infrastructure stack, working with, let's say, tools like Hadoop and Spark and whatnot,
Yes.
sort of like get your first models out the door.
So you were close to data, like starting from like data systems and data engineering and all, like in Rocketwell. And was your work in LinkedIn also roughly this along the same
Yeah,
lines?
yeah, yeah. So at LinkedIn, I was sort of like in an interesting role where we were trying to build out the economic graph. So of course, you can imagine that every single company eventually gets to a level of sophistication where beyond which they need to rely on machine learning techniques or heuristics to sort of like advance the business further. And this is back in 2015 that LinkedIn was at the same spot where they wanted to deepen their understanding of how the economy was shaping up, what kind of job opportunities were available, what kind of skills were available, how do you match people to those jobs and those skills. And in that pursuit, they wanted to build out this knowledge base. That was called economic graph, and you can imagine sort of like that has its own sort of like share of challenges both on the data science and the engineering side, that would like simply quite interesting to sort of like pass up.
Understood. That's great. Uh, I would like Savin to understand uh, like prior to Metaflow, and we would love to introduce like Metaflow first and then Outerbounds. Like, what were the other systems that you had encountered in your previous companies like LinkedIn and Rocket Fuel, and
Mhm.
what prompted you to like think about Metaflow, or what prompted the birth of Metaflow? So,
Yeah, yeah, excellent question. And in all of these places, there were sort of like two solutions
hmm,
predominantly that were widely prevalent. So one was just having more people around, right? So if we don't have tools, then let's just have more people, right? And that never works. It never scales. It just like unfortunately slows everything down. And also, I don't think there were good tools that were available for these sophisticated organizations either, that they could sort of like just buy or adopt from the outside. So they ended up building much of the tooling internally. And I would characterize that, the last sort of like decade and a half has been all around just experimenting with tooling as well, just figuring out what are the right patterns. And I think it's only now that we are sort of like, at least on the predictive ML side of the house, uh, learning what the best practices are that can be codified into tools. But it's been sort of like multiple decades in the making in many ways.
I see. So, as you mentioned, like, but were there so was there any tool being used, or was it just more people at the problem back then?
No, I mean, there were definitely tools being used.
Okay.
I remember, we sort of like built back at Rocket Fuel a feature store. We didn't
Okay.
call it a feature store back then, but in many ways it was sort of like, similar in
Yes.
spirit
Yes.
to many of the solutions that you see out today. We ended up building sort of like auto ML solutions as well from the ground up, HPO solutions too. And I wouldn't say that any of those tools were sort of like quite at the level of sophistication at which you
Understood.
sort of like see many of these things today, and also primarily for the fact that many of these companies were also making their move to the cloud as well. So compute was also not really sort of like as easily available. I still remember being in these capacity planning conversations where we had to commit 6 months ahead that, okay, here is basically what our
Mm,
requirement from an ML point of view would be. And then there would be another team that would go out and ensure that, all the compute capacity is sort of like provisioned ahead of time. So if you just look at a variety of different trends that have panned out over the last sort of like 5 to 10 years, I mean, the kind of tools that existed 10 years ago, quite frankly, just wouldn't work today. I mean, it would sort of like,
correct.
feel like what you need is a Ferrari, and what if, let's say, you're still sort of like latching onto tools from 10 years ago, then those would be kind of like a bullock cart in this era.
And back then, like, did you have? I'm not sure what I don't remember exactly, but did you have things like Airflow and all like recently mature or things like that?
Yeah, yeah, yeah. So they were sort of like, bunch of workflow orchestrators.
Mm,
So I remember one of the first ones that I came across when I started my career was this thing called Uzi that came out of Yahoo. And
okay.
then LinkedIn was very much into Azkaban, which was their
Hmm.
workflow orchestrator. And then Netflix had sort of like a few more. I think this is sort of like, something that's quite common with workflow orchestrators, that as your company matures up, then you'll end up having multiple workflow orchestrators,
Yes.
each for a specific use case. I think Netflix had sort of like, at one point toyed with introducing Airflow internally.
Hmm.
Then the workflow orchestrator that they were using for their recommendation systems called Mason, that then ended up becoming their workflow orchestration system of choice for all their data engineering workloads as well. And now the
Yes.
most recent reincarnation of Mason is called Maestro. And I think the
Okay.
team at Netflix has written sort of like publicly about sort of like, what the architecture looks like and the kind of workloads that they are pushing through. But definitely, I think, the big learning was that just like, there isn't sort of like one single universal database that can take care of all your application concerns. It's the same thing with workflow orchestrators as well.
Understood. And then how did the Metaflow journey start? Like, what is the problem statement? What solutions did you explore? How did you come up to the solution?
Yeah, yeah. So that was sort of like, very interesting journey as well, because if you think about data engineering, right? I mean, data engineering sort of like grew on top of the application engineering stack and the BI stack. And it was predominantly based on JVM, Java, and Scala. And
Correct.
sort of, if you look at many of the predominant projects in the space
Hmm.
a decade ago, Hadoop, Spark, they were all sort of like, had their heritage in that universe. And for the longest time, Netflix's machine learning investments were also built on top of that stack. But
Okay.
if you look at, let's say, mid 2010s, with the advent of like TensorFlow, PyTorch, many of the sort of like, other tooling that was coming along, that was predominantly in the Python ecosystem, right? So that sort of like stack started to sort of like become a lot more prominent. And now you ended up in a world where more practicing data scientists were gravitating towards a Python based stack, where usability and utility was
Hmm.
a lot sort of like, highly prioritized, and experimentation was sort of like at the forefront. And in many ways, the big data stack just did not provide those affordances to a data scientist, right? I mean, I think it's still the case in many organizations where if you have your data engineering pipelines running on Spark, you may need to go out and hire a Spark expert, right? And now, of course, you can't necessarily imagine your data scientist to be an expert in Spark as well as an expert in data scientist, right? I mean, it's
Correct.
like even if there are unicorns in the world, I believe that there are not enough unicorns in the world that you can
Yes.
go out and hire. So we found ourselves in that situation that okay, like we have data scientists uh,
Hmm.
who want to get more work done. The appetite at Netflix around introducing machine learning to other parts of the business is also growing pretty rapidly. So imagine, like Netflix is very famous for its recommendation algorithm, but it is very likely that that may not be the most uh, prominent machine learning system that they might be operating. So Netflix, just like any other content business, needs to create a portfolio of content any given year. It needs to
Hmm.
figure out what content it should host on its service, how should it go about licensing it, how should it go about producing it. Content production is a very human intensive, very expensive affair. How do you optimize that?
Correct.
If you're, let's say, responsible for one third of the internet's traffic, then you also have to be intelligent about how do you route that traffic, because
Hmm.
otherwise it might be commercially untenable to run a streaming service at the scale of Netflix.
Makes
So
sense.
there are like many such problems where you can be either data driven or data informed. And all of those approaches can rely on data science to sort of really move the business further along. And you can't sort of if let's say you have to focus on any of these problems, then you have to ensure that the people who are working on these problems, they have full autonomy, they have full control over how they want to solve that problem. They are the subject matter experts. And unfortunately, on the data science side, you have to cross two gulfs of complexity, right? One is on the data science side, the other is on the engineering side.
Right.
And now data scientists, very technical, very smart people, they understand, they enjoy taming the complexity of data science. uh, they would want somebody else to take care of the complexity on the engineering side. And we basically were in a spot where many of the tools that we looked at, or many of the tools that were already available to our data scientists, uh, either missed the mark on removing the engineering complexity, or
Hmm.
they also encroached on the freedom of choice that a data scientist would have wanted, right? I mean, I wouldn't want a data scientist to come to me and tell me how to manage a compute cluster. And at the same time, I think it would be unfair of me to go to a data scientist and educate them on sort of how to build their machine learning models as well. So
Right.
how do you sort of maintain that balance becomes
Mhm.
really, really important, especially if you're looking at productivity tooling, which is basically what our task was. That if we have to go out, if we have to hire a lot of data scientists, how do we make sure that they're able to experiment and innovate effortlessly without sort of transforming themselves into um, an expert on sort of the entirety of ML infrastructure stack. So
Like,
we started working on Metaflow back in 2017, and then by late 2018, early 2019, the entirety of Netflix machine learning was running on top of Metaflow. And then in 2019, we decided that it might sort of make a lot of sense to open source what we had worked on. We had sort of a lot of inbound interest. People wanted to see sort of what we had built. And you can also imagine at times it becomes important to ensure that the world sort of moves in a concerted direction, and you don't
hmm.
sort of miss out on a trend. So for example, if let's say we had continued building our ML infrastructure on top of a JVM stack, and if the world moved in a different direction, then it increases the cost of building any new internally in the company. And that was sort of one of the biggest prerogative in terms of open sourcing what we had built, just to ensure that if we have built something of value, then it may very well sort of ensure that we move in alignment with the wider machine learning community.
Understood. That's great. And what were like some of the challenges while building Metaflow? I'm sure like it must be like it's a great achievement to have the whole company down on Metaflow, but I'm sure you must have gone through a lot of challenges and the adoption process in the company. So if you can shed some light on that.
Yeah, I mean, it's like every day is a new challenge. So it's in many ways too many to recount. Plenty of things on the engineering side. So you can imagine at the end of the day, what we are geared towards is providing a really good experience to the data scientists, right? So we want to make sure that when they are doing things, in many ways, the proper guardrails are placed around them behind the scenes, so they don't even sort of recognize that that is the case. And one big thing that we wanted to do was, can we basically bring the power of the cloud to a data
Hmm.
scientist's laptop, right? So you can imagine, if let's say as a practicing data scientist, you may want to access a lot of data. Maybe you cannot pull that data to your laptop because of security concerns. Maybe that data is humongous. You want to access a lot of compute. You do not have access to as much compute on your laptop, even if let's say you're sporting the latest and greatest MacBooks and whatnot. And how do we make it effortless? How do we sort of create an end user experience where it feels as if you are still iterating and experimenting on your laptop, but all the
Hmm.
compute, all the data movement happens in the cloud, happens with latencies that sort of makes it feel that yes, everything is actually sort of very much interactive. And that then sort of leads to very interesting engineering challenges at the end of the day, right? How do you actually move gigabytes and terabytes of data, saturating your network bandwidth so that things happen as quickly as possible? Or how do you ensure that as data scientist is experimenting, then all the proper guardrails ensure that they are able to build a higher quality work artifact by default, so that you can minimize the amount of extra legwork that a data scientist would have to do to sort of like come back, refactor their code, or sort of like introduce sort of like more hygiene to make certain things production worthy. And now the interesting thing is that all of these concepts, they sound sort of like good in theory.
Hmm.
They were sort of like good conversations and podcasts like these, but when you actually sort of like meet with the reality, and you have to sort of like work with data science teams day in and day out and ensure that you really sort of like understand what their real pain points are, and what are sort of like all the small little gotchas, all the sort of like dead by thousand cuts, what those thousand cuts are, and really
Yes.
sort of like address those. I think that's the real grunt work, and I think that was the benefit of Netflix's corporate culture, that it allowed us to embed in many of these data science teams, become the de facto ML engineers to really understand what were those pain points and really sort of like offer those solutions, and then sort of like just pray for organic adoption beyond that.
Nice. That was great. And what was the feedback like you're getting from the data scientists at Netflix? Like, when did you realize that this is like really valuable and nothing like this exists outside at that point? Like,
So I don't think there was sort of like an actual moment in time
okay.
where we sort of like had this realization that yes, what we have built is sort of like significantly different. Um,
Hmm.
Definitely, there were times when we looked at sort of like alternate approaches, and we had this question that okay, if we had to build the same thing all by ourselves, we would sort of like maybe take a very different approach. And then it was basically a compounding of many of those decisions over a rather long period of time that sort of like brought Metaflow to where it is. And I think the interesting sort of like facet for us was when sort of like when people sort of like go out and start recommending to their colleagues or other folks who may not have heard about the tool or the solution, that that should be a solution that they should be sort of like using, that's when you really know that yes, you're onto something. Because it is kind of like a rarity. Like there are like very few tools that people will advocate for as their favorite tools or pet tools. And you can imagine what ended up happening was that we had many excellent data scientists at Netflix who left Netflix to go elsewhere. And of course, they did not have Metaflow available to them at that particular point because it was not open source, right? So that sort of like also ended up creating a lot of inbound interest in terms of just like sharing what we had built.
Interesting. And I guess that's the point when you also like took the plunge to start out of bounds, and like, how did that journey
Yeah,
like?
yeah. So we it's interesting. So we open sourced Metaflow December of 2019 at AWS reInvent, right? And now, fortunately, unfortunately, there's a lot of cargo culting that happens in tech, right? So of course, like if something comes out of any of the big tech companies, you would see some natural adoption, and many times that natural adoption may not really be an accurate reflection of the quality of that project. But then early 2020 was also a very interesting time for the entire world in many ways. And so, like that's when the pandemic started. And one of the silver lining of the pandemic was that it really sort of like accelerated tech adoption in companies, right?
Correct.
So companies who may have sort of like chosen to invest in machine learning or data science, let's say, a couple of years down the road, in many ways they were sort of like staring at doing that in a matter of months. So we were able to basically take advantage of that and really understand what kind of adoption were we seeing in the community. And in the next sort of like 18 odd months, we were seeing sort of like clear signals where many large sophisticated businesses started using Metaflow for the most critical aspects of their machine learning applications, right? And when that happens, and when that happens consistently, then in many ways you have de-risked the business, right? So I mentioned sort of like how my career thus far has been sort of like a long lineup of experiments. So it's sort of like on the Metaflow side, the first experiment at Netflix was that okay, let's sort of like build something and see if this is something that sort of like people internally at Netflix will enjoy. And then of course the next experiment was that will people outside of Netflix will care. And now the third experiment is that will people care enough to pay for it. And
Yes.
like now we're sort of like trying to figure out like if that is the case or not.
Nice. And how has the experience been after joining Outerbounds? I know, like, working in a big company, and I myself have been through the journey, so and so I can relate to what you're saying completely, but just want to hear from your experience, how has the journey been?
Yeah. So in many ways, it's very different than working at a company like Netflix, but then at the same time, it's very much similar as well. And I think that has sort of like, all due credit to Netflix's culture, to be honest. So Netflix thrives on providing extreme autonomy to teams.
Hmm.
And as an early stage startup, you also get to enjoy extreme autonomy in the sense that you are sort of like on the hook for the smallest of decisions as well as the largest of decisions. So from that point of view, nothing much sort of like changed from a product building standpoint.
Hmm.
But of course, like there's sort of just like the daily vagaries of running a business, and of course the fact that at Netflix you could just like walk over to your customer's desk, versus that may or may not be possible at a startup. So it's been sort of like super fun, I would say, the last sort of like 3 odd years that we have been at it. And we still work very closely with the folks back at Netflix. So that sort of like relationship has sort of like continued uninterrupted in many ways. So it's good to sort of like have that semblance of continuity on that front.
Nice, that's great. Uh, Savin, we get a lot of questions from our customers regarding the lot of pipeline orchestration tools,
Mhm.
and I'm sure you know about them like better
Yeah.
than me. Like there's Metaflow, Flight, there's Baxter, there is Prefect, there is Airflow.
Yeah.
So, want to get your sense on like, and I'm sure like one is better for one use case while the other is better for. There is no like as you mentioned, there is not one thing that fits every use case, right?
Mhm.
So how should like users or ML practitioners think about when to use Metaflow, when to use something else, and what is the use case where Metaflow really shines?
Yeah. So, excellent question. And, I think it's less about sort of like, figuring out when to use Metaflow versus when to use other solutions, but more about what is the mental model of what does an ML infrastructure stack looks like, and where do many of these solutions fit together, right? Because many times comparison between, let's say, a Metaflow and an Airflow may not be an apple to apple comparison. Right. So the way sort of like I tend to look at this entire ecosystem is in terms of a layer cake of sorts, right? So if you are, let's say, responsible for building a machine learning system or an AI system, then of course everything starts with data. So you need a place where you're able to host your data, you're able to access data, you're able to manage your models. So some place where you're able to sort of like manage the state, right?
Right.
And there are multiple solutions for that. Many organizations may have existing data platforms. People have sort of like invested in things like feature stores and many other things. And what Metaflow provides in that particular layer is model management, all your
Hmm.
artifact and state management, all the work that you do in terms of building your machine learning models. Metaflow is able to sort of like store that, snapshot that, so that things can be reproducible. So that sort of like is the sliver on the data side of the house that we are able to take care of, right? Then the next thing that sort of like comes up is all around compute, right? Now, depending on the needs of your organization, your requirements around compute may vary significantly. You may need sort of like, a planet scale HPC cluster versus sort of like, maybe your needs are sort of like a lot more modest, and maybe sort of like, just running things on your laptop may suffice at times. And how do you basically span that entire spectrum becomes a big question, especially as a data scientist. Right now, if you need to access any amount of resources on the cloud, then do you sort of like automatically become an expert on these HPC systems, or let's say Kubernetes? That may be sort of like a tall order. But now, an interesting piece of complexity is that, of course, we have spoken about data, we have spoken about compute,
Right.
but what about the interaction between data and compute, right? How do you move data to your compute instances and back, right? How do you monitor and manage that? Yes, if you're, let's say, um, using GPUs, then you're actually utilizing those GPUs, and you're not just sort of like burning money. So these are all the questions that again Metaflow sort of like answers, which many workflow orchestrators will sort of like just purely put out of scope in many ways, right? And then if you sort of like go a level higher up, then there is sort of like this thing that, okay, how am I authoring my work, right? Like
Hmm.
if I have to author this compute, if I have to author this data processing, how do I actually do that? And Metaflow provides an SDK that looks very workflow centric SDK.
Hmm.
And of course, if you are using a workflow orchestrator as well, those SDKs are obviously going to be very workflow centric as well. But now the interesting difference here is that if you think about, let's say, something like an Airflow and many other solutions out there, they are excellent solutions once you've figured out what that workflow is, and now you want to run that workflow reliably. But when it comes to iterating and building and developing that workflow, then that may not be sort of like, the strongest suite for many of these solutions out there. And that's sort of like one of the big use case that we have. So in fact, you can basically just do pip install Metaflow, deploy no infrastructure, and you can start writing your workflows, and you can scale out to the cloud. You can run hundreds of thousands of containers in the cloud just by sort of like, connecting your Kubernetes cluster without sort of like deploying anything onto your Kubernetes instance. Or you can connect it to AWS Batch or any of these other managed compute offerings that are available out there. And so it's sort of like very simple and straightforward to get started. But then the one sort of like big question that comes up in many of these organizations is that, okay, of course, like I've been able to build this workflow. Now, how do I deploy this workflow, or how do I run this workflow at some cadence reliably? And as I mentioned, right, like there are solutions like Airflow and many others that might actually already exist in any organization. And the good thing is that with Metaflow, we are able to transpile all the work into, let's say, something that an Airflow can understand, that AWS step functions can understand, that Argo workflows can understand, so that people then don't have to do the busy work of translating all their experiments, all the work that they have done, into something that can then sort of like, these workflow orchestrators can take and sort of like run reliably. So that's the gap that we sort of like end up bridging. And that's the linkage that we have with workflow orchestrators. But then as you sort of like, go beyond that, then there are questions around that. Okay, how do you visualize your work? How do you bake in reproducibility? How do you think of dependency management on the machine learning side of the house? How do you think about model deployments, which again, sort of like, in many ways would be characterized as out of scope for workflow orchestrators. But if you're building a machine learning system, you still need sort of like, many of those components. So in a nutshell, one way to sort of like characterize what Metaflow is would be sort of like, let's say a glue layer across your data platform, across, let's say, your compute platform like Kubernetes, across your workflow orchestrator. And then it sort of like plugs in all the gaps, especially at the interfaces, as well as provides solutions to all the MLOps concerns that an organization may have.
Interesting. Actually, yeah, that is one of the cool, fascinating features about Metaflow, that I don't need to change my code to change the orchestrator underneath. So
Yep.
you can migrate from like step functions to Kubernetes without really changing the code, and that's pretty cool, because most of the other orchestrators, like, you literally have to rewrite the code, which almost becomes a very strong lock-in with that infrastructure,
Mhm.
with the orchestrator infrastructure, basically.
Yeah, yeah, no, definitely. You can imagine, we had the same question internally at Netflix as well, that there was already a data engineering workflow orchestrator called
Hmm.
Mason that data engineering teams were using. And if you think about machine learning workflows, they sit downstream of data engineering workloads, right? So
Right.
in many ways, it is a feature if you're able to run your data engineering workloads as well as your machine learning workloads on top of the same platform. But then the skill sets that data engineers are bringing to the table are not necessarily the skill sets that ML engineers or data scientists will have. And then also the machine learning workflows have very different characteristics than data engineering workflows as well. So we are trying to sort of like, bridge that gap, especially when we look at the workflow orchestration sliver of the machine learning infrastructure stack.
Interesting. And how has like how do you follow this LLM, and what's your view on all of that? There's a
Mhm.
lot of advancement happening on the generative AI space. Just wanted to hear your viewpoint on that, and
Yeah, yeah,
yeah.
yeah. No, I mean, of course, like the world has changed tremendously over the last very many years. And I think the interesting bit here is that at the end of the day, there isn't any value in building machine learning models, whether predictive AI or predictive ML or Gen AI. Where there is value is in building these machine learning or AI systems, right? So let's sort of like, take the example of Netflix recommendations, right? If you think about Netflix recommendations, then it's not one single machine learning model that is powering that experience, right? It's sort of like many different ML models that are responsible for painting the view that people see when they log into Netflix.com. And it's likely that some of those models are LLMs, especially when it comes to conveying the value of a particular show and why you should click on a particular recommendation and watch it. But when it comes to actually generating those recommendations, it's very likely that those might be non-LLM models. And you can imagine, like similar things may sort of like pop up on the e-commerce side as well, that if you, let's say, log into some website wanting to buy some product, and then the actual recommendations that are served to you may have nothing to do with Gen AI, but then all the descriptions and the customer support functions that might be associated with that product fulfillment might all be Gen AI driven. And to me, that's the most interesting aspect, that how do you take all of these approaches, marry them together so that then you can sort of like, really deliver a differentiated machine learning offering compared to your competitors.
Interesting. And just Savin would love to hear from you like some of the success stories of Metaflow, like
Mhm.
for our customers and for all like people working on ML and
Mhm.
AI. If you can just elaborate a bit on the success stories or the impact that you have seen when a organization onboarded Metaflow, and what was the change that you observed?
Yeah, yeah, no, definitely. I think the most heartening part of sort of like, shipping some product is when customers take that product and are able to deliver value further downstreams to their own customers. We have sort of like, this one company that has been using Metaflow for a really long period of time called Zipline.
Hmm.
They're an autonomous drone company, and they were basically responsible for a big majority of drug supplies, including COVID vaccines in sub-Saharan Africa through autonomous drones. And these autonomous drones are basically running a variety of computer vision and acoustic models to find their way to the drop zone, and then sort of like, back to the supply area. And sort of like, really heartening to see how Metaflow was able to sort of like, enable data scientists at Zipline to sort of like, get that thing going. We have companies like Amazon Prime Video, Disney, Warner Media, Roku, who use Metaflow, besides Netflix, of course, to sort of like, power their sort of like day-to-day consumer experiences. Um, Companies like realtor.com, zillow.com, when you sort of like log into their websites, and when you see sort of like any prediction around how the rents or the prices are going to sort of like change over any period of time, many of those features are also sort of like, powered by Metaflow behind the scenes. So seeing sort of like, that kind of adoption, like day-to-day products that you and I sort of like end up using, and knowing that yes, behind the scenes, it's sort of like, some of the software that we ended up writing, that's sort of like, creating that magic. That's always sort of like nice to know.
That's a
It's like,
great idea.
yeah,
That's a great feeling, Savin. Like, yeah,
exactly, exactly. Like, it's like companies like Dyson, for example, that have always admired for their engineering. And when you get to know that there's significant amount of ML behind the scenes, or companies in the drug discovery space, right? Like imagine sort of like companies like Sanofi, Intuitive Surgical, Medtronic, 23andMe. They're all sort of like, in many ways operating at the bleeding edge, um,
right,
increasing our understanding of sort of like, how to tackle diseases like cancer. And that's like real world impact at the end of the day, which is sort of like
nice.
is quite heartening.
And the last question, like Savin, for today is, how would you say like the Outerbounds adds on uh, to the experience of Metaflow, or how do you make it easy for companies to use Metaflow? Like just a brief introduction about
Yeah,
Outerbound.
yeah. So I think one learning, or like one of the biggest reasons why Metaflow was successful at Netflix, was not because of what we built, but because of the fact that we were standing on the shoulders of the giants. So there were
Hmm.
teams that were already building incredibly good data platform, incredibly great compute platform, great at managing availability and reliability of our workflow orchestrators, great observability platform and whatnot. And Metaflow was basically packaging up all of those capabilities and providing that to our data scientists. And open source Metaflow is great if, as an organization, you already have access to all of those building blocks. But it is very likely that you may not have access to these building blocks, and it may not well be worth your time to invest your resources in sort of like, building a great compute platform, while those resources can be sort of like, devoted towards sort of like what I would call differentiated heavy lifting, what sort of like, creates a difference between you and your competitor. And that's where Outerbound steps in. So we are able to sort of like, not only provide you a great experience using Metaflow, but
Hmm.
all the underlying concerns, the entire infrastructure cake
Okay.
I sort of just called out a few minutes back. We take that, we manage that on your behalf, and then all the data, all the compute is private to you. It runs in your VPC, so it sort of almost feels like Outerbounds can behave as a machine learning platform as a service, or a machine learning platform team as a service, which is basically how we characterize our service today.
Interesting. Cool. Awesome. Thank you so much, Savin, for answering all the questions. It was lovely talking to you.
Yeah, likewise. Thanks for having me.
Thank you.